Good morning and welcome to the CADclass Podcast. I'm Josh,
I'm Jake.
and each Wednesday we come on, we talk all things CAD, Fuion360. We answer your questions. We go through our Discord server. We talk books. And today we've got a big announcement, I think. So stay tuned. We're going to announce it just a little bit later, but we've got a big site-wide sale. Big site-wide sale.
We really do. Yeah. Black Friday for those in America, Cyber Monday for those around the world.
Yeah. And for all the unreasonable. So you don't have to buy a physical thing and clutter up your house, is what we're saying. You can learn some new skills from CADclass.
Absolutely.
So good morning, everybody. It's good to be here. Thank you so much for joining. If you are new here, and if you're not new here, pop a comment in the chat. Say hello. Tell us where you're calling in from. And feel free to ask your questions as we go. So we're going to start by, first, I want to start by congratulating two in 1 week. Two graduates, two people have completed the entire CADclass curriculum. And I want to shout
Which I think is a record, 2 people in 1 week.
That's pretty great. Yeah. Hey, nice to have you back. Maple Leaf Makers, I haven't seen you for some time. It's nice to have you. PC Van Vliet is a staple.
As always, regular.
Thank you for joining us, PC Van Vliet. So 2 graduates in 1 week is probably more than we've had since we launched on Reddit when we did our trial.
I know.
We had more people. Marion, welcome. Hello. So we have 2 graduates this week, and just so you all know who are on here, we're really excited to highlight and showcase your projects, your achievements, and so when you graduate, we'd love to have you on the podcast. And I just got a note here from somebody. I don't know if it was okay. So when you graduate, let us know. And hopefully you'll get a chance to pop on and chat with us one of these Wednesday podcasts. We'd love to highlight what you did, ask you questions about how it went. We're always trying to learn from you and hopefully, give back to our community in any way possible. So congratulations to, let me find, who did we hear? I made it in the announcements tab. And we got it, by the way, awesome audience. We had like 40 people react to the first one and almost 20 people react to the second one. So that was really cool. So congratulations to Vasil, who we have mentioned on this podcast before.
Oh,
and congratulations to Dryand, who I don't think we've mentioned. And I don't even know that she commented very much. But they both completed the final chapter this week. So huge shout out, huge congratulations.
It is definitely a philosophy of Josh and us that we absolutely could make this course and this book easier, just to make it, nicer for people. And we don't think that's the right way to learn this kind of a software. Big wins in the beginning are important, but if we don't challenge you guys in any really meaningful way, then we've kind of failed as teachers. And so the fact that we see people actually going through the entire thing and finishing is a genuine accomplishment, because we don't hold back for any of the projects, really. If something is difficult, we'll tell you. We'll tell you. All of the hours at the very beginning of all the projects where it goes, this will take like 3 hours. We've had people come back to us and go, "You're lying. It took me 7 hours." Well, 3 hours if you rush.
Yeah. I want to shout out something really, truly special this week. I tweeted it out. So if you're following us on Twitter, you might have already seen it. But one of our graduates, and I'll say her first name, she actually was part of our Reddit cohort, got a promotion because she went through our class. She was promoted to engineer on her team.
That's fantastic.
She took on a big 3D modeling project. Her name is Amy. I won't say her last name.
Amy did it.
Yes. And she tackled a big 3D modeling project and impressed her bosses so much that they gave her a bump and a new title. So she was promoted to engineer. So huge congratulations.
Congratulations, Amy.
That's so freaking cool. We love to see when you take these skills and make your own custom stuff, get jobs, get promoted, make the world a better place.
Yeah, absolutely fantastic. Congratulations, Amy. She was part of our beta testers way at the beginning.
Way back.
And she was doing engineering projects, I believe in environmental engineering, all around the country. So she would be like on a train while in our meetings, trying to be super quiet because it's 2 a.m. where she was.
Yes.
but absolutely stuck it out.
So
Oh,
rad.
that makes me so happy.
So rad. Yeah.
That's phenomenal.
Hey, Jostri. We are, so we, did I say hello? I don't know if I got you, Todd. Welcome, Todd. Welcome, Jostri. I think
Hello
I
to
said
everyone.
hello to everybody else. I'm not 100% sure about that, but yeah, good stuff.
That's really great news. I like
So
it.
congratulations, graduates. Congratulations to those of you actually advancing your careers, advancing your lives, starting companies. This is why we do it. So super, super awesome.
Or just having fun.
Or just having fun. That's fine too.
I think that gets lost.
You're
There's
right.
a really big part of advertising for CAD programs where they go, you can make a jet engine, you can make a robot, you can make this, you can make that. And it's like, that's great. That's awesome that you can kind of show off just how powerful your program is. And it's like, oh, shoot for the moon, you can do anything. That's great. But I think you and I both share the same sentiment where big projects are really fun, but making super duper small, tiny little projects that just improve your life minutely are so satisfying. And so when people end up posting on our Discord and they go, I just made this tiny little thing, this little tiny thing, and it really helps me out because of XYZ. It's my favorite thing in the world. I love it because I know that rush, that excitement that comes from like, I did a thing and it worked. It's like, yeah, it did. It's awesome.
Oh,
So
he's
I love
even
seeing that.
lead with the love. Wow. I'm good. Enjoying a burrito and watching CAD class. Josh's soothing voice and Jake with Fusion Gold. I'm good. That is
Thank
so
you very
nice. Now I'm like, I feel like I need to talk even deeper and slower.
I mean,
because
we
this
do
is-
have the NPR mics, so this
we
is
do. We do.
yeah.
Oh, I love it.
All right.
Love it. Okay, so we made the announcement. So right here in the very beginning, so we said we're going to be unleashing some deals on you all. So for any of you who do actually want to go through any of our online classes, and we've teased this a couple times, we are drastically improving our 3D printing series and going completely from scratch. Jake, you're in the middle of filming that right now.
In the middle of production, yeah.
Gonna be awesome. But if you sign up for any of our classes online, just know that you're probably going to be watching some of the older classes, especially in the 3D printing series. But as soon as those are new, you will get access to those new ones. So, Jake, what kind of discount are we offering for anybody who wants to go through all this?
We're offering 50% off every single course that we offer. And I think even more importantly than that, we offer perpetuity access. I'm subscribed to a few, online education centers, and it's like as soon as your subscription runs out, you're done. Or even if you pay for the class, it has a timer on it. It has like a year until it's gone forever. You're like, no, you bought it. You should have access to it forever. But also,
yes.
every single year that we update either the Fuion360 portion or any of the 3D printing or any of the Cura or anything that we offer, you will always have access to the newest content. Always, because you paid for it. If it changes, the information will change, but it's still going to be.
Yeah, I think
it should always be accessible.
exactly. It's annoying that everything is a subscription and that you almost don't feel like you own something. Like it's not, you don't get to keep it anymore and people just take it away from you. So we're trying to kind of do something against that. So if you or anybody you know does want to take the class, we've got a Black Friday sale now. We're not going to say through when, but it's at least through Cyber Monday, and we'll update this as we go. So if you or anybody you know does want to take the class, now is definitely the time to sign up. This is the biggest discount I think we've ever given on that.
Yeah.
And if not, we always give the book away for free. So there's absolutely no pressure. And obviously you can also purchase the book on Amazon. So all good there. Okay. So
really weird thing as well. Any single time that we see people going like, "Oh, thanks for the discount on Amazon," we don't control that at all.
We don't. The book is $2 off on Amazon right now, and we have no control.
We have zero control over it. So people just come to me, they're like, "Hey, when are you doing your next discount on Amazon?" I don't know. I have no idea. When book manufacturing becomes ever so slightly cheaper to Amazon, that's just how it goes.
Totally. Let's shout out some projects. This is like one of my favorite things to do as well. So let's shout out some projects. We have so many amazing projects coming in this week.
I know.
We asked all of you, and we're going to continue to tell you week after week, we're going to be putting photos of projects in the blank pages of our next book, just to show off what you all make and to inspire other people to want to do it as well. I think for me, like the easiest way for me to get through a program is to see other people who have succeeded in that program.
Absolutely.
And so we're just trying to highlight some of the amazing stuff that you all have done, showcase you. As we said before, this is all about you guys. You guys make what we do possible. So we want to make sure that we're giving back as much as possible. So if you do have something to share, put it on the I Made a Thing in Discord. We want to see it.
Yeah. And if you say, I want this to be in the next portion of the book, include a little blurb about it, just so we have a little bit of context for it, and we'll very likely put it in the next copy of the book.
Totally. And that's very
All right.
nice, BC Van Vliet. The book makes an amazing physical present. We hope so. It's full color. It's nice to look at. Alrighty, Jake, what you got?
All right. So jumping into our I Made a Thing, Joe Street again. Is Joe Street on the stream right now, Josh?
He was. Joe Street, you still there? Maybe. We'll see here in a second.
I don't know.
Yeah.
So Joe Street is the same guy that's been working on some combat robots, some battle bots for a while. Definitely something that I'm becoming more and more in love with as the days go by. I actually watched my first episode of BattleBots last night. They have a bunch of seasons on HBO, and for some reason I'd never seen a single episode of my entire life. Even as a kid, I was like, yeah, whatever. And then I watched it, and it's absolutely hysterical. It is so funny. Like, they're all dressed up in like ridiculous costumes. All the robots have silly names. Like, they have a robot voice that goes like robots activate at the beginning of every single fight. There's a referee, like in boxing, where if your robot doesn't move, they have like a counter. They're like 10, 9, 8. It's absolutely amazing. And like there's obviously cameras everywhere, and so like they get like really serious on the remote controls. And then at the very end, as soon as the game's over, the two contestants, they come in, shake hands, they hug, and everyone's friends again. It's just such rad energy. It's so nice. I really, really love it. And so I'm definitely going to be pursuing this in the future. I'm definitely going to be making some battle robots in the future. But I want to make something with like a flamethrower. I just don't know how to do it safely.
Screw safety. We don't have to do anything.
Yeah, whatever.
Forget that.
But coming back to this, so Joe Street's made a bunch of these very small scale versions. So for those who don't know, in the world of BattleBots and combat robots, they have a series of weight classes, and it changes based on countries as well. So you can have something, I believe it's called ant weight in the US, where it's like 1 pound. So obviously that's not a ton of weight for a robot. So usually they're about, I don't know, smaller than a laptop usually, and they're all 3D printed. And then if you want to go even smaller, they go down to a fairy weight or a feather weight, where it's like 150 grams, where it's like, yeah, it's getting tiny. You have to be really creative with how your weapons work, your drive motor, even the size of your battery. That can be really important. And it goes all the way up to these gigantic ones that can weigh like 250 pounds. And then on the opposite end of the spectrum, they have micro weights where it's 25 grams.
That's
and I'm like, that's insane. Where it's like a drivable thing, and it also has to have a weapon, like a flingy or a fire. Like, that's crazy. That's amazing. But Joshi looks like he's working on a shuffle system. Finally figuring out how to use the assemblies components using the book. This is, I'm not sure I understand exactly what
it looks like a cam. It looks like a cam, almost like a camshaft. What is this?
Yeah, so I'm not sure. So he's got two separate bolts on either side. Oh, so it's a shuffle mechanism. So in my mind, this is like to shuffle along to move, like it's a worm drive. I think this is probably a worm drive in the middle. I think we're viewing it 90 degrees. Like you've got some selectors in the middle, and then this is moving around. Either way, yeah, I think that could be rad. I think that could be super cool. I love that kind of stuff. Yeah. Joe Street, please post more stuff.
We love it. We love it, especially when you compete with your BattleBot.
I know.
Awesome. I know. We got to see it. Just yes.
Josh, I definitely think we should potentially sponsor some robot people in the future.
I think so. Yeah, I would.
When we have dough to dish out. Yeah, I think that'd be fantastic.
Absolutely. Yep. Yep,
But I
yep,
would,
yep.
but I would love to do. But I would love to to sponsor the 25 gram weight.
Yeah,
Right?
yeah.
Like the sticker is a gram. Like, oh
Yeah.
god. Yeah, absolutely. That's
Uh,
fantastic. I love seeing that stuff. And then coming up to Milksy. Milksy posts a lot of stuff on here. We always love to see that stuff.
yeah, what's really cool about this one too is this looks like it was heavily based on the design we did in the book, but
Mhm.
modified. And the way he
Yeah.
modified it was very interesting.
Mhm. So this is kind of skeleton class, where it's removing as much weight as possible to make 3D printing faster, less material usage, for a little iPad stand. We're just gutting a lot of material, and it still works just fine. I think it must have been printed in that orientation going up. I was thinking it was like
Sideways, no?
on its side, but I'm not
I think
seeing any sagging whatsoever on this top surface.
yeah, it's tough to tell. I don't know.
Hmm.
It looks really
I don't
nice.
know.
It
I
looks
know.
like, and it works.
For some
And
reason,
it works.
for some reason it won't let me zoom. Oh, there we go.
Yeah. So this is like, to me, this is an excellent example of a project that we want to showcase in the book. Like real people making real things. I even like that you can see some of the background stuff. Like I feel like it
Yeah,
gives you this sense like, oh, people make this in their houses.
yeah. Making little stuff like this where it's just to make your life that tiny bit percent easier, and
Yeah.
it's something that you design yourself is just so rad.
So
I
satisfying.
love seeing
So
I love seeing that
satisfying.
stuff.
That was
And
the
then they
original.
made
That looked nice too. It almost made me want to have one of those in metal.
that's
You
pretty
know,
sweet.
I don't know if you guys are familiar. I think we may have mentioned this last week, but a company called Send Cut Send here in the United States, it's based out of Nevada, sends you incredibly cheap custom made parts so you can have metal 3D printed by somebody else. I think one of the things that our audience sometimes fails to remember is that you don't actually have to make everything yourself. Once you've made that
Yeah,
CAD design, you can tell other people to make that for you. That's the power, I think, of CAD is
I
doesn't have to
it's
be you.
I think for a lot of people that I think most people don't know that much about the world of like prototype engineering, um, and we do, and we know a lot about the costs. Um, Coming up with an idea, that's awesome, and then giving that over to an engineering firm and saying, "Hey, design this, figure out, all the problems, how to solve it, the manufacturing problems, and then give me a prototype." And I needed this in 8 months. Easy, easy. That could push 50 grand, 100 grand, 150 grand, depending on who you go with and what degree of specialty. They will just tack on more and more and more and more prices. Like a very simple prototype made out of 5 bits of plastic that were probably 3D printed, they will charge $1,000 for that. Easy peasy. But if you saying, "Oh, but I already have the CAD skills, I can design it, I know how it's going to work, I can 3D print a prototype,
Mhm.
out of like an FDM printer where it's not the highest resolution, but it's like workable." And then you send it off to other companies to actually then manufacture that to a really high degree of quality and then confirming that it does work. You could easily save yourself 100 grand along the process of prototype development or of product development as well. It's
So
crazy.
I was talking to a product developer here too. So excellent point. I was talking to a product developer here who runs a makerspace, Tim Keller. You met him at Maker Fair.
Mhm.
So Tim said he sometimes, because he's already made some designs, he could buy stuff on Amazon, but it's sometimes cheaper to have it custom made by Send Cut Send than to purchase it on Amazon.
What?
Hmm. So some of the designs and things that he does, he's like, I'll just have them make it. It's like,
That's crazy. That's
what?
absolutely insane.
So Maple Leaf Maker says they aren't cheap in Canada, but they competitive at least. So yeah,
Yeah.
unfortunately, this is probably somewhat United States specific. I know Xometry's here in the US, SendCut Send's here in the US. There's a handful of other companies who do it. SendCut Send just happens to be the one that seems to have mastered it. Just
Yeah,
really inexpensive
I
parts.
think
I
so.
don't know how they do it. So
No idea. Magic.
and in the future too. So one of the future projects that Jake and I have been talking about is doing stuff like BattleBots, where some of our students may not have access to the materials they need. So in the future, I actually do want to go through the whole process of how to make something custom that you send to a place like Send Cut Send and have them
Mhm.
deliver it back to you. And that way, if sorry Canada, sorry world, for those of you who don't have so much access to this stuff, but hopefully as more people learn how to do this, that access improves, your ability to do this kind of stuff improves, and so you know how to kind of collaborate with other people more than just making it yourself.
Yeah,
All
absolutely.
right,
Or
what else do we
even
have on here? Sorry.
I just to expand on that,
Mhm.
a lot of people in the BattleBots world, obviously they are for the larger projects, they're obviously made up of teams, most of them being engineers and machinists and manufacturers. But even on the small scale, apart of what I've found just with a little bit of research, um, your local area, very likely your county, will very likely have a BattleBots community,
Mm,
and they will probably know a lot of people
mm,
outside of that field as well. So they'll go, oh, it's really expensive to make this part by this, by this company in my country. But then reaching out to a friend in the US or somewhere in Eastern Asia, where manufacturing these very custom parts can be fantastically inexpensive, and then just shipping it may be more inexpensive. Who knows? But the community side of this is just something that I really love. I
love
love to
it.
see that.
I love it.
Anyway, moving onwards.
So this is kind of cool. So
Wookie O. So I have not
Wookie
seen this yet.
Oh, Wookieeo. I don't. Yeah, maybe that's Ohio. I don't know. That's what I
I
saw
think
in
it's
my
Wiki,
head.
Ohio. Yeah. I designed this simple shelf to fit in my Sunlu filament dryer, so I have an easy way to dry my silica beds. Okay, I'm gonna.
Silica beds, beads.
Oh, beads. Excuse me.
I was like, silica beds. What the heck is that?
So I actually have this Sunlu filament dryer.
Mhm.
It's like $50. It runs all night. Really easy to figure out. I'm gonna do a little bit of a Jake rants, if you don't mind.
Jake rant. Let's wait.
Jake rants.
Wait. Before you start the Jake rant, we're gonna go ahead and hashtag Jake rants.
It's
Okay.
I'm a little bit embarrassed about like
All right, let's
how
go.
annoyed I get.
Let's
Okay.
go. Jake
Okay.
rants.
Let's break down to the very, very basics. I'm gonna stop sharing my screen. So okay. When you buy basically any product in the world, it'll usually come with a little packet of silicon beads. These absorb moisture in the air and prevent things like mold and different bacteria from growing. So those are the little packets that say "do not eat." So okay, that's fine with everyone. When you buy any amount of filament online, it will also come with an even bigger pack of silica beads because they absorb any of the moisture, and any moisture that goes into 3D printing filament will cause defects in your print. All filament is called hygroscopic. Basically means it absorbs moisture from the atmosphere, and then when it goes into the hot end, those small particles of moisture get turned into steam and then basically puff up and turn your print into foam. That's why you can hear little crackles, little pops for older filaments. So that's fine. So when people are done with their spool of filament, you should put it in a gallon bag with some of these silica packets, zip it up so no moisture goes into it. That's great. Side note, a similar thing can happen if you store your filament in like your garage, but your 3D printer is in your office or in your house, which is obviously warmer, which mean in the same way that like a cold beer coming out of a cooler will start to condensate moisture from the air onto it, in the same way that you shouldn't store filament in a cold place and then bring it into a warm location, because moisture in the air is going to grab onto the cold object, and that basically does the same thing as storing it improperly. That's fine. That's fine. What nobody told me for years is that silica packets have a saturation level. They will absorb moisture, and to the point where they can't absorb any more. Okay, I understand that. But then nothing changes about them. Like there's no color changing aspects to it. And then if you have a bag with filament in there and you've like, I've got like 10 packets of silica in there. Why is it still really brittle and cracking and full of moisture? It's because at a certain saturation level, they will actually emit moisture into your print or into your filament. So when you're storing it, it's like you're putting it in an even higher moisture saturation than if you were to store it in your open room. Super annoying. So when people say, "Oh, you should dry out your filament," absolutely, please do that. At the same time, you need to dry out your silica packets even more regularly, and nobody told me this. So I have
Wait.
ruined.
What is the color changing stuff?
the color changing stuff, I think Maple Leaf is talking about the as soon as it's like a strip of paper, and as soon as it reaches a certain
The moisture.
a certain
Okay.
moisture level, humidity, I guess,
Buy the
then
big
it
jug of
changes
color changing
color.
stuff. Yeah. Link to it if you could, Maple Leaf Makers. I want to
Yeah,
see if that's what you're actually talking about. And
recharging.
then
Maybe it's
recharges in the
silica.
microwave. Great
Might be
stuff. Color
silica.
changing silica gel beads. What?
Oh, yeah,
What?
that's probably the way to go
I
then.
did not know this. Okay. That's very good to know.
Mhm. I've seen people where they have like a gigantic tub, and they just buy like a liter of these silica beads, and they just pour it in there. So it's always just as exposed as possible. I don't know how well that works, but yeah, most time when I see people posting on forums like Fix My Print on Reddit, where they go, why is nothing working? Why my filament's looking terrible? A lot of the times it's like, yeah, you bought crappy filament. I'm sorry.
Yes.
You cheaped out. There you go.
Was it something on Twitter this week got a whole roll of filament that was just bogus. It was way too wet, and it just like disintegrated in their printer. It's like just piles of crappy
This
filament.
stinks. Really
Dry and
stinks.
Dry
Yeah.
brand. Can't post links, but it's on Amazon. Dry and Dry brand. Okay, so
All right.
color changing silica beads. That's an awesome tip. Thank you so much, Maple Leaf
I
Makers.
did not know about that.
I did
That's
not know.
fantastic.
We should know about that, but
Yeah.
we did not. So thank you.
Yeah. All right.
Is that the end of Jake Rants?
I think that might be the end of Jake Rants. Yeah.
Till next
done.
time. That
Until
was
next-
Jake Rants.
All right. I have a new toy that I got to play with this week.
Yes.
So with all the Black Friday deals going on, we were able to pick up a new 3D printer. So I've been playing around with the Ender 3 V3 SE, which I think is now the hardest name for any printer.
If you're listening, Creality, what's up with this whole naming convention thing? Come on.
Just do a
Ender
V4.
3, V3,
Come on.
KE, SE. What is happening?
Like they have J-Crants, they have the worst naming conventions of most 3D printers, because they had the Ender 3, which was rad. Everyone liked it. You can upgrade a little bit more to Ender 3 Pro. Then they had the Ender 3 2. Then they had the Ender 3 Plus. Then they had the Ender 3 X. Then they had the Ender 3 X1. And the only minute differences.
Wait. I need to. This is important. This is important right here. Mhm.
Thank you.
Go on.
Like that. I don't think I've ever seen a picture of the Ender 1. The Ender 2 is actually really rad. It's super small. But yeah, Ender 3 was fantastic, but that was like 5 years ago. It still has an area where it's fantastic in this world, but let's move on. Let's go on to the Ender 4, please.
Speaking of moving on, the Ender 3 V3. Tell me about it, Jake.
Ender 3 V3 SE. Who knows what the SE stands for?
Yeah.
This is a new edition. We got it for $150. I think it normally goes
Shipped
for $200
to our door for $150.
Yeah,
That's insane to me.
that's fantastic.
It's insane.
So it's. I think people were getting the Ender 3 Pros for like $100 now, which is mind blowing. But for this printer, it is a direct drive, which means that you can now print TPU and Ninja Flex much easier. For everyone that doesn't know, usually you can split up 3D printers into two different categories, into a Bowden drive and a direct drive. Essentially, is there a little tube that connects where your extruder motor is actually pushing material, goes down a tube and then into your hot end, or is your extruder motor directly above your hot end? The benefit of having a direct drive is that there's no distance in between where the material is being extruded to where it's being melted. So if you have a really stretchy material like TPU, which is a really rubbery material, that's what phone cases are made of, like really flexible ones, then it's fantastic. The downside for a long time was that now you have another motor on top of your hot end. So it has a significant amount more mass, usually twice or three times as much weight on it. And so as you're trying to move the hot end back and forth, you're now having to reduce the speed, reduce the acceleration, because you're adding in so much more momentum into this. And you'll usually get a pretty poor quality because you'll get all this extra micro chatter, is called. that is now a thing of the past. These machines are now flying at way faster accelerations than I ever thought. This printer has got a max acceleration of 4,000 millimeters per second squared, which is insane. My normal Ender 3, I usually print at 500. But I've been printing this at, I think it has, I think a lot of people are like, yeah, you should probably run it at like 2,500 millimeters per second squared. And I'm like, okay, that's fine. That's fine. So I printed off a little acceleration test. I don't think you guys can tell
It's tough
on
to tell.
here.
Tough to tell.
Yeah. The idea with these little acceleration towers is they'll usually have letters X above them. And one of the parts of acceleration is that if you see a ghosting effect, like whatever the letter X, for example, and then right next to it, like fading away, X, 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 and it gets fainter and fainter, then that's usually too high in acceleration. Lower it down a little bit. You want it as high as possible, but to reduce this ghosting effect. Yeah, 2,500 millimeters per second squared. Insane. I've been printing these 250 millimeters per second. Oh, sorry, 250 millimeters per second for the speed, which is not mind-blowingly fast compared
fast,
to like the Voron, but for me, for all the projects that I do, damn fast. It usually halved on the old Sidewinder. Yeah, on the X1. Yeah. Those things are absolutely insane. And I think we're now starting to see this really fantastic kind of climb where not only are we getting, I think we've talked about this in the past, where not only are we getting still incredibly affordable and accessible printers that have got all the goodies that we want in them. They've got, bed leveling probe, they've got stronger springs, they've got a metal extruder, yada, yada, yada. But now you're able to print faster and faster and faster with a better quality. We're getting, obviously there's machines that are $1,000 plus. Those are going to be, the hallmark of, the pinnacle. That's great. That's awesome. But there is kind of I'm completely forgetting the name, where it's the curve where you can get better and better and better. And then as you pay more and more, you get less and less and less out of it. And this seems like really, really fast, but without a ton of cost. It's like, yeah, I could spend 5 times as much, but I wouldn't get 5 times the speed. Do you know what I mean?
You're talking about the semiconductor thing, where the speed of semiconductors.
Yes. Yeah.
What the heck is that called? All of a sudden, I'm forgetting the.
Totally forget. You can essentially spend more and more and more, and you don't get that much. So there is a sweet point where it's like, it's not as fast as the best thing in the world, but for your money, it's as good as you can get. If there's an area of reasonableness.
BC Van Fleet. Yeah. My dash hound freaks out when the printer goes burr. That's pretty amusing, actually. Moore's law. Thank you. Moore's law.
Perfect.
That's it.
And so with this printer, really fantastic. So direct drive, so I'll be printing some really cool things out of TPU. One of the things that I've been wanting to print for a while is my own pair of running shoes, 3D printed running shoes that I've been wanting to make for a long time. So I'll definitely be making those. This past weekend, I just did a mud run, or a rugged maniac run down in Temecula, California. And oh my God, it kicked my ass. I was so exhausted. Sliced open my knees and my hands were all cut up. Ton of fun though. And I actually ripped my shoes in half going through some barbed wire. And after doing it, I was like, I'm just going to throw these shoes away, whatever. I was like, if I wore some 3D printed shoes, would they survive? I don't know.
We'll find out.
I know. So I'm definitely going to make some. I think running like a half marathon in them would be a great test. I think they'd probably completely
maybe start with a 5K or a 10K.
Maybe that's a test. Maybe I do 5K, 10K. I've run a couple half marathons. I've never done a full marathon before. I really want to. It's on my bucket list. So I might try kind of scaling the ladder. That sounds like a ton of fun.
Nope, that does not sound like a ton of fun. That sounds terrible. What we didn't get through, let's go back and we got a couple more really cool projects to showcase. I want to show off Jerry's insane cooler, which is really, really cool. Jerry also was one of our early graduates.
Mm-hmm.
Enter the matrix. There we go. Scroll up.
Yeah, this project was rad.
Look at that.
But he's now working on a cooler.
Look at that thing.
That's right.
Says
Working
he's
on
adding a
this at the
step so you can
moment.
see the details. He's even added the step file, which is actually really cool of him to do
Oh,
that,
that's rad.
right? So
Damn, that
all the joints
was
work, theoretically going to be produced in Sweden. So
wow.
Jerry didn't know CAD when he started our program, or at least didn't know it well.
No,
Maybe he had done a little bit of it. And now
he
here
was
he
a
is developing
software engineer
products as a
for years.
professional product developer. I don't think that's the
I know,
only thing that he does, but dang, that's interesting.
I know. It says there's a battery pack, a solar panel to charge it, Bluetooth board, not modeled, USB-C port, speaker, hinges, wheel magnets.
So
All the
cool.
joints work theoretically. That's amazing, dude.
So
That's
cool.
rad.
So cool.
So
Nice
fucking
work,
cool,
Jerry. We have
dude.
Dark
Hats off to you.
Knight just above that. So first, let's see, SD card holder. Yeah, SD card holders.
That's
That was honestly one of my
yeah.
favorite things that I printed when I first got started with 3D printing, and it was such a game changer. When Jake and I were working together at the workshop in Southern California, uh, you could never keep track of those things until I
Oh god.
printed a holder for one specifically, and I said, "They all live here," and then we didn't lose one again. So,
Yeah.
awesome thing
Yeah.
to print.
Your first functional prints that you get from like Thingiversal printables.
Mm,
Oh my god, that's an addictive. That's an
it's
important
that's a
point in
milestone.
everyone's 3D
Mhm,
printing. Yeah,
mhm. And then
I think it's
Otterleg, working on some earring holders for a friend that tack to a door and will hold both the longer
that's
style of
awesome.
earrings and studs. Otterleg, I think I've been seeing some of her stuff on Twitter as well. Just awesome. Look at
That's
that. That's
rad.
a fun. I really like that design.
I do as
It's
well.
it's fun. I like the hexagons. Something about probably back to my organic chemistry days. Hexagons are just
Mm.
they have a special place in my heart.
I'm
If
getting
there's a
nightmares
test
from that.
coming up, it's a negative place. If not, it's nostalgia.
I know. That being said, have
Um,
you seen those graph paper, but it's hexagons for OChem
I have, yeah.
instead of
Oh, yeah.
a linear
Oh, yeah.
grid? Oh,
Oh,
those are so
absolutely.
rad. I want to
Yeah.
get some of that. I've no need. I've no need whatsoever, but I just want to get some.
And then just
And then
above that, we've got the working on some decorations for a Nutcracker performance and decided to make customizable LED snowflake.
oh,
Cool.
that's awesome.
Stems hold a
That is
10
so rad.
millimeter LED strip and you can bolt and slide them on. Nice tight V groove. Awesome.
Oh my god, that's
Awesome.
fantastic.
This is the type of
That's the
stuff
kind of
that's
stuff
going to
I love
live
seeing.
in our book. Ah,
Yes,
love
this
it.
is what we want to see. I didn't sing
Just
yesterday.
above it, this is the type of stuff that won't live in our book, but you're still welcome to talk about. I think this is a gun part. So, no, thank you. But,
Not for us.
awesome. Cool that you're designing stuff. And then
So
above
rad.
it, Otterleg again. Check these combs out. These combs are awesome. Designed these fancy combs in Fusion the other day. Look at those.
That's rad.
Those are so rad. Those are so rad.
I
And
love to
then
see this stuff.
PC Van Vliet, Mr. Mitnick,
Hey,
right there. That's the same, right? Um, let's see. I don't.
love seeing
What
this
am I
stuff.
looking at? What am I looking at with PC Van Vliet? What is this? Maybe you can tell us in the
I
chat. What?
am not quite sure.
Yeah, you're gonna have to tell us what this is.
Hmm. I don't
Hmm.
know. It looks like he's recreating a part. He's obviously took a picture of this. Hmm. Is that metal or plastic? I have no
I
idea.
can't tell. We're gonna have to.
No idea.
Yeah. And then Jerry again. Was that okay? That was older. So these are now we're
Yeah,
beyond the past
we're
week.
beyond the beyond. But I love to see this stuff.
Amazing. Did we have any questions coming into our
Let's do some
Discord?
questions as well.
Yeah, let's see if you've got any questions. Well, there is some new stuff coming out in Fusion 360. So I don't know if you guys have seen the most recent update, but there's a possibility that you have access to a new feature that allows you to automatically place bolts into anything that has holes. Haven't tried it out yet. We'll probably test it live next week on
Yeah, I think
YouTube.
that'd be good.
Yeah, we'll just
Yeah,
pull it up and start playing around with that feature set if we can. I don't think you have access to it yet, Jake, but I, for some
not
reason,
yet.
do.
So Josh has the education license because he is a CNC professor. I don't because I'm just some guy on the internet. And I really want to mess around with it. It seems of what I've read in their update article that they do, it seems to be a combination of like the Mastering Fusion 360 plugin and also the duplicate joints, where essentially pick a bolt and then just click where it wants to go and it just pops it in place. Sounds pretty cool.
It really does,
The
yeah.
configurations I haven't seen that yet.
I have it on the education license again. I don't know if it will go to the free tier. Yeah, that's a question. I read through some of the documentation on the Fusion website and watched some of their videos, and it's unclear. It might be there. I didn't catch if it was. So unclear if it will go to the free tier. But tip for you, Maple Leaf makers: if you are a startup under 3 years old and you sell a physical product, Fusion will give you the professional version as a startup for free for up to 3 years. You just have to renew it each year. So I highly recommend, if you have an Etsy store, if you have something simple up for sale online, go to the Fusion website and change from the free version to the startup license, which is the full professional version.
Which is $500 a year.
Yeah.
So it's essentially $1,500. And one of the things that we cover in our course that isn't in the book is exactly, literally step by step, how to do this, how to develop a product, where to sell it, how to make a very quick website for it. This is something that Josh has a lot of experience in. And then essentially how to then submit this to Fuion360, to Autodesk, so then they will reach back to you. They say it'll take like 2 weeks to get back to you, but we've had people where they develop or they take a few weeks of our class, they develop a product, they sell a few on eBay or Etsy, they follow our course where they make a little website for it, they submit it to Autodesk, and literally like within a weekend they get approved for it.
Yeah,
and it's like,
it's been pretty quick, and it seems there's very specific criteria. So
Mm.
just make sure you hit the very specific criteria the way that it's supposed to be. Like they don't do it for people who are selling services. It's just product-based stuff, I believe.
Yeah.
But we had a question in here. So Edward says, how would one go about making print-in-place hinges?
Ooh, print-in-place hinges with great difficulty. So one of the things that I actually really enjoy about describing what CAD is to people, and this is going to it's going to start high level, and I'll bring it back down, is the whole purpose of CAD is to give information or to convey information about a 3D model. So in the world of woodworking, if you're making a really interesting box, everyone does the kind of hand motions, and in your brain, it makes all the sense in the world. And in the other person, they're going, I have no idea what you're talking about. You're just doing a lot of hand movements. So the idea with CAD is that you can convey information very easily. When I've done a few tutorials about print-in-place hinges, latch mechanisms, I always try and do this, where it's like just hand movements, and the other person has no idea what I'm talking about. So I think this will be a good project to do. I'm going to go ahead and share my screen. I'm going to make a very, very simple hinge, and it's going to look very ugly. Okay?
And it's for a print-in-place hinge?
A print-in-place hinge, yeah.
Okay, yep. Cool.
Essentially, to go through the whole process. It's going to be ugly, and I'm going to try and do it as quick as I can. All right. Can you see my screen, Josh?
I can. Yep, you can blow it up. You can probably choose the even bigger option here. There we go. Get our faces off the screen.
No, but our faces are lovely. That's what everyone's here for. Okay. I'm essentially going to be making this. Normally, you'd make this as multiple components. I'm just going to be making this as multiple bodies. So the idea is that instead of having an axle that runs through the entire thing, we're basically just going to be making two sides of a hinge and then a center. And they're actually going to be rotating by a cone, a revolved cone, and then a revolved inverted cone with a little bit of tolerance on either side. This is because this cone is going to be sideways at an angle, because all printers can basically 3D print at a 45-degree angle just fine. So I'm going to be doing a a mirrored revolve print. So I'm going to start out by making an axle right here. I'm going to make this a center line. And then this line right here, which I'm going to be mirroring whatever I draw over here. This is just going to be a normal construction line. So the idea with this is that, I'm going to be making 45-degree angle cones with a little bit of tolerance on either side, so that when we revolve it, it is perfectly, perfectly smooth, so we don't get any ribbles to it. So in this scenario, we've got a certain amount of tolerance. For this example, let's say there is a 1 millimeter difference between the two sides of the cone. I think it actually will want me to make these solid. There we go. Let's say that the total diameter of of this hinge is 10 millimeters. We want to make both of these totally collinear. Make the tops collinear to each other. It really doesn't matter the size of this whatsoever. But let's say the whole thing is 40 millimeters, so this will be 20 millimeters. And then we'll just shuffle these over a little bit. We'll actually make them equal. That's fine by me. Okay. And then, as I said, all 3D printers can print at 45 degrees. So we can do 90 plus 45 or 135. Then I'm going to be mirroring all of this, except for the axle and that, about this line over here. Whoops, oh, it didn't carry along the bottom line. That's fine. So when I revolve these, all of these profiles about this bottom axle, I essentially have two sections that can be joined together, and then another section on another side for a hinge. But the idea is that you've got this cone that fits inside a three-dimensionally negative cone, so they can revolve completely independently from each other, and there is no axle or pin that runs through the entire thing. Does that make any sense at all, Josh?
Yeah, it does. Yep.
Yeah?
Yep. I think we also talked about even potentially having a section in our next book dealing with 3D printing, like design specifically for 3D printing. And I think print in place has such a huge part.
It's definitely more of a complex thing to talk about. But yeah, it's something that a lot of people have asked us for.
So Edward says, yeah, that makes sense. So there you go. Yeah, if you want to replay this video when it's done, then and try to recreate what we've just done, start playing around with that. Maple Leaf Makers also has a question. I don't know if you're finished with this one, Jake. It looks like you're still jamming. Oh yeah, there you go.
I'm just jamming.
Just add the hinge part.
I'm just messing around.
Yeah, okay.
All right, give me the question.
So I do have another CAD related question. Is there a way to do parametric text for customizing name tags, etc.?
That's a damn good question.
I don't know. I don't know.
Let's experiment. Let's mess around. Okay. I'm just going to make a very simple box. That's a great question. Let's say I want to make this name tag 50 by 100 mil. And I want to put in some text on this page. So normally, if I was just doing this without having that really good idea, if I was just going to say Jake and Josh, normally I would just type it in there and then extrude this up. And then anytime I wanted to make a new one, I would just go back into this sketch and then edit whatever name this is. But you're suggesting that I should make it parametrically, which is very, very interesting. So let's try and do that. So let's go into parameters. And the first thing that's going to come to mind is to actually make this a unitless situation. So most of the times parameters are saying, oh, the width is 25 millimeters, but that may change. If I'm working on a woodworking project and I measure my wood and it's like, it's not 25 millimeters, it's 23 millimeters. I can adjust it here, and then my entire model will kind of maneuver and stretch and expand to fit this new dimension. With this, it's not just lengths. You can also get currency, luminosity, mass, temperature. Essentially, any value, any unit that you can apply can be a parameter. But also, you can say no units. So you can just have this as the number 10 as 10 things. So you can make it a quantity if you want. So if you're doing a pattern and you don't know exactly how many holes are going to be drilled into a bit of wood, you can essentially say, I would like 10 by 10, and then, no, let's put it back to 8 by 8. So for the name here, so the expression would be name, and then this would be Jake. Does that make sense? It doesn't like name. I don't know. No, excuse me. Oh, for an expression, I think it has to be a numerical value here. Yeah. So it won't be able to be. So the only times you can ever type in an actual word into this is if this is already a parameter. So if you're saying the height is width times 2, that would work, but only if width is already something that you have saved in here. Currently, it's like, I don't know what width means. It doesn't mean anything. Therefore, this isn't allowed. This is red. So unfortunately, parametrically, that would not work in this scenario.
Well, I'm curious. So I do, like, what is Maple Leaf? What is, maybe give us a little bit more specific information about what you're trying to do, because customizing text doesn't actually take much time. So like, I'm kind of wondering what the use case is. Like, what are you trying to achieve? I guess is the question.
So here's something that that I don't have a lot of experience with. I have experience with it in a different program, not Fusion, but I'm almost positive that there is a plugin. If you go into utilities, I almost guarantee that there is an add-in or a plugin where you can actually bring in a essentially an Excel spreadsheet or a Google Sheet spreadsheet, and type in 100 names and then plug into that, and it will then produce 100 STLs with different names on there. That's probably a thing within Fusion. It's definitely a thing in Thingiverse. I know there's a lot of nameplates where you can actually go into. I completely spacing on the app, but it's something like Customize Me, where you can essentially have a spreadsheet of all of the different parameters that you can change. So you can type in your name or any words you want. Oh, you want 2 words stacked on top of each other. What's the width? What's the font? And it's literally just typing in different values and then click go, and it will then give you an STL with all of these parameters. You don't need to make it in CAD. You're literally just typing in some text boxes.
Well, and so
I think that's probably the way to
that's
go.
another interesting thing is the what I guess I would call it the CADification of slicing softwares. So as
Mm,
slicing softwares get more sophisticated, they're actually turning into like kind of like lightweight CAD programs,
definitely,
is what you're
definitely.
starting to see. And I think you're seeing that with the Prusa slicer for one, and I think he's
Mhm.
even mentioned that on the blog. So don't always assume that the best way to do something is going to be inside of Fusion. It may actually be post processing and in the slicer itself. So don't know, because I haven't played around with that functionality yet, but it's possible that it's more efficient to do it that way.
Yeah, I definitely agree. It always falls into that category of, well, what are you actually trying to do, and how easy is it going to be to do it one way or another?
Mm.
And if CAD is the right tool, then CAD's the right tool. But there are some scenarios where it's completely the wrong tool to use, and you will just make your life so much more difficult if you choose to do it that way. Yeah. Sorry, I'm just not paying attention to you, Josh. I'm just making a hinge.
I like it. I like it. You may as well
All right.
finish.
I may as well. Sorry, I'm.
Keep going. Yeah,
I know I'm
I like it.
supposed to be doing work right now, but
No, this is great. This is great. I think this is half the reason I think people show up, is seeing some design in real time, feeling bad about yourself for not being as good as Jake, which we have some of in the chat. I just said, yeah, this is what 10 years of frustration do. So,
I mean, basically, yeah,
mhm,
basically,
yeah, doing things wrong hundreds and
a
hundreds of
million times.
times until you
Just
eventually don't do
magic.
them wrong anymore, or probably still do them wrong.
Yeah, yeah.
Yeah.
All right.
We've got about 5
I
minutes left. So you got
okay.
something else for us,
That's
Jake? I'm gonna quickly make
perfect
an
for me.
announcement.
All right, go
If you
ahead.
have any more questions, please do drop them in the chat. We don't have all that much time to answer them, but back to you, Jake.
Okay. I have a request. It's Thanksgiving for us tomorrow here in the US, where a lot of families get together and we gorge on food and then we fall asleep. And some of us go, let's play football. No, I want to sleep, dude. But everyone likes to have lots of
No
turkey,
sports ball for
lot,
Jake.
lots of potatoes, lots of stuffing, lots of veggies. Love it, love it, love it. And a lot of people get into decorations. My mum's one of them that really gets into decorations. And she found these very, very adorable little paper turkeys. I know. Very, very cute. Love it. And one of the things that happens when you have a 3D printer is that people will say, "Can you make me this thing?" Yeah, of course I can. Of course I can. I can, yeah. And she goes, "Great, I need it for Thursday." I go, "All right, cool." And she says, "These are all fine and dandy, but because we're in California, she wants table settings where these turkeys are on surfboards and all the surfboards have our names on it." So- and she says, "Can you 3D print them all?" Going, "Yep, yes I can. Yes I can." All right, now I'm gonna do it. So I'm gonna try and essentially make a turkey-sized surfboard with my name on it, and then export it as an STL in 4 minutes and 13 seconds. Okay.
Go.
All right. Okay. Go ahead and share my screen. And I'm going to, if you want to still have us, both our faces on it, Josh,
Sure.
because I'm going to be basically bring out some calipers. All right. So first things first, this is basically just got a little turkey with a toothpick on it. So I just need to basically, this is an artistic thing. So I'm literally just going to hold up a pair of calipers up to it and then see, what looks about the right size. So that's 90 millimeters. That looks about right. This is literally how most people do CAD. So I'm going to be extruding up or a mirrored profile of a surfboard that's 90 millimeters long. Make this construction. Or actually, no, I'm going to be making this a center line, excuse me. So it's all symmetric. And then extruding it up, putting a little hole in it for the toothpick so it can pop in there. And then extruding up some names. So it actually shouldn't take too long. So I am totally making this all these values up as I go along. Say for the flat section of the back, 25, that looks about right. So the nice thing about making this a center line is that I've now got, instead of just point to line, point to the other side of the line. There we go. And then I'm going to pull in a fit point spline. Whoops. Click on the point. There we go. The trick with a fit point spline is the fewer points that you have, the better. So that looks a little bit too bulky at the back. I'm going to put that down to like 20. Josh actually is a professional surfer. So does that look about right for the side profile?
Yep, looks pretty decent.
Yeah.
By
I like that you're just
professional, you
glossing
mean
over that you're not.
I am
you're actually
absolutely not a professional surfer. I am a terrible amateur surfer. And compared to most people
No.
in the water, yeah. Compared to I attempted to learn to surf for 6 years. That's what I'll say. And I can occasionally surf a decent wave. But
I think
professional is not the way I would describe that.
no.
A
Josh
ridiculous amateur. A ridiculous amateur.
All right, that looks like a surfboard profile to me. One of the things with splines is that you don't put any numerical values on it. So if you want it to stay still or be fully defined, you have to use the fix unfixed constraint. That's where all these green points are. I need to put in a little circle for this toothpick to pass through. So it's going to be somewhere along this center line. I'm just going to measure this toothpick. This is 2 millimeters. So I'm going to say this is 2 millimeters. I want a tight fit on it. So I'm going to say plus 0.5. The general rule with 3D printing is if you want a tight fit, add a 0.5 millimeter tolerance. If you want it to be a loose sliding fit, make it a 1 millimeter. That is the rule of thumb.
PC Van Vliet says he is a no pro. Yeah, that's correct. That is correct.
Essentially, yeah.
T minus
All right.
1 minute, Jake.
All right, where is this going to live? That's going to live.
See what you got.
Yeah, 40 mil from the back. 1 minute. Easy peasy. Great. Cool. Let's extrude this up. That's the nice thing about Fusion. It has an arrow because this is purely artistic. 3 millimeters. That's just fine. Groovy. Make a sketch. Add some text. Cool. Jake, make this a little bit smaller. Make that 5. Center, center, center. Groovy. Point to point, point to point. Make that horizontal. Cool. And then let's extrude that up. Don't want the whole face. Just want that. Up 1 millimeter. Cool. Right click on the body. Save as mesh. Whoops.
You gonna add some small
Save
fillets
as
or no?
mesh. All right, fine. Josh, I have to do this in a minute.
You lose.
Ugh.
That was just, I was just trying to sabotage
Throw
you.
me off my rhythm, man.
Just sabotage you. Like, come on.
Total sabotage.
We'll call it, you got it. It's pretty good. You had to open the program. Looks good. Looks good.
All right. I think that's about fine
That's
for
awesome.
a turkey surfboard. There you go.
Well, everybody, this has been the CADclass Podcast. Thank you so much for joining us. And once again, it looks like we don't have all that many people here anymore, but 50% off everything on our class website right now, cadclass.org. If you know people that are looking to up their skills or just bought a 3D printer or something like that, please do refer them. We would love to have them be a part of our community. And again, there's no need to buy anything if you just want to work through the book. But this has been fun.
This has been rad. All right, guys.
CADclass Podcast. See you next time.
See you guys.